Let's move on the second session of the day by the keynote speaker, Dr. Anthony Xavier, Head of the Department of Mathematics, Loyola College, Chennai. I call upon Ms. Alirani, Department of Computer Application, to introduce the speaker, Dr. Anthony Xavier.
We would like to welcome our second keynote speaker, Dr. Anthony Xavier, Head, Department of Mathematics, Loyola College, Chennai. We thank you, sir, for accepting our invitation and being here with us to enlighten with your wisdom, knowledge, and expertise. He completed his UG Mathematics in the year 1992 at Government Arts College, Krishnagiri, University of Madras. PG Mathematics in 1994 at St. Xavier's College, Manonmaniam Sundaranar University. In 1995, MPhil at Loyola College, Chennai. And in 2020, PhD at Loyola College, University of Madras, Chennai. He has teaching experience of 25 years in graduate level and postgraduate level for 19 years with dedication and commitment to his assignment. He had been a core member of LIMCOS from 2017 to 2018. He has a research experience for 11 years on the topic of graph theory and theoretical computer science. He has guided almost 11 PhD students and 6 students are pursuing right now. He has published 85 articles in both national and international journals. He has presented more than 29 articles in conference proceedings, has been a keynote speaker for various national and international conferences, has been honored as conference chairperson for many workshops and conferences, has been a convener, scientific committee member, organizing secretary for national and international conferences, member of the editorial committee. He has authored 10 books. He had been a president of Mathematics Association, a member of outreach program, industrial interaction coordinator. So it's my great honor and pleasure to welcome such a noble personality amidst us. We are blessed to have such a knowledgeable and wisdom-filled person as our keynote speaker. We look forward to your expert talk and presentation. The platform is yours. Over to you, sir.
Thank you, madam. Hello.
Check.
Respected Reverend Sister Secretary is magnificent. Respected Principal Reverend Sister Pushpam. Respected Convener Reverend Sister Dr. Santiago Teresol. And respected faculty members, scientific committee members, and my dear students and my dear participants. Good afternoon. So it is, I know it's your lunch time. Actually, my time is 11:50 to 1 o'clock. Now it is 1:03. Okay, so hardly I'll take 20 to 25 minutes. So don't worry. So So before going into my session, I also would like to share something with you, because on seeing this group, I used to recollect my schooling and college days. Can you guess why? ஏன் தெரியுமா? I am also like you from a rural place. My schooling was near Krishnagiri. It is not even in Krishnagiri, that's town, nearby Krishnagiri. Okay, some small village. Up to 11th standard. For 12th, I moved to Krishnagiri. And my college was in Krishnagiri Arts College. Okay, comparing to your college is 10 times better than my college. Just imagine. So, my dear students, you are in a very good space. You are in a very good space. See, right from Krishnagiri, I moved to Loyola College, such a wonderful place. Why can't you to shine throughout the world? It is possible, okay? It is possible, definitely. So with this message, also I would like to share some more things. Actually, after my schooling, I wrote entrance exam in those days for engineering college. Entrance exams was there. And actually, some 35 years back, I got more than 1,000 marks, right? Okay. And I applied engineering, but my father, he was a school headmaster. He strictly said, no engineering, only mathematics. PSC mathematics தான் படிக்கணும். My father's command. I got engineering. Actually, I got first rank in that +2, right? Yeah, father mathematics படிக்கணும்னாங்கன்னா, my father tried to study mathematics, but he was not able to study. So he forced me, right? Note the word. He forced me to take mathematics. Actually, in my college days, I used to hate mathematics, right? But even I used to hate chemistry. Now my students are doing research in chemistry, right? So this is the fact. What I'm going to say is, okay, after taking mathematics, I settled in mathematics. And actually, in those days, I entered into Loyola College in 1995. At that time, my students, after completing UG, they used to go for IT jobs, right? Okay. One of my student, okay. So one day he came. I was working in evening college, Loyola College, and simply he asked, "Sir, what is your salary?" I said, "My salary it was very low salary at that time." He said, "Sir, my salary is 4 times better than your salary, sir. What is this?" He said. And he also explained his job's nature and so many things, right? Okay. Recently, I met him. You can't believe he has developed BP, sugar, and almost all type of diseases. My student, right? எனக்கு அதெல்லாம் கிடையாது இன்னும். That is the beauty of teaching, especially mathematics teaching, right? As I tried to escape from mathematics, my father forced me to do mathematics. Same thing happened yesterday. Actually, I tried to escape from this conference. My sister, my students, he forced, no way, you have to attend the conference. So when sister forcing me at that time, I recollected my father, right? So, thank you, sister, at any go. Actually, Dr. Jagadish Kumar, he was talking about practicing mathematician. Okay, see my life, practicing mathematician. Proudly, I can say, I am a practicing mathematician. I am teaching in Loyola College. With that, I cannot say practicing mathematics. Apart from that, I used to write a lot of competitive exam books. Somebody mentioned I have written 10 books. It is not correct. More than 25 books I have written. Actually, have you heard of Sakti Publications? It is for competitive exams. Sakti Publications. In mathematical parts, almost all mathematical parts were written by me. Actually, I am working as a freelancer in that Sakti Publications. It's the leading publications for competitive exams, right? Not only that, see, my origin is from Government Arts College, Krishnagiri. Now, I have taken classes for IIT students, MIT students, NIT students, all type of business school students. And also now, due to lack of time, I'm taking CSIR net show classes through online. So that's why I myself probably I can say I'm practicing mathematics here. See, my origin was from arts college, but I was able to take all type of students, including IITs, topmost students, right? Okay, they used to post problems of all level of difficulty. So we used to sit and we try to solve the problems. Okay, so that is the meaning of practice, right? That is the meaning of practice. Once you start practicing means you can achieve whatever you want. If you want to earn in terms of crores, you can. If you want to go to of the globe, you can. Anything is possible. The only thing is you have to practice. The word practice, it has a lot of meaning. So my dear students, so try to understand. You are a mathematician. Nowadays, everybody is talking about machine learning, right? Machine learning. Machine learning, one golden subject is this. Sir was talking about golden ratio. I can say this subject is a golden subject in mathematics. Can you guess what is that? Golden subject in mathematics. Can you guess? It is nothing but linear algebra. Without linear algebra, actually, sir was presenting the whole presentation, no? The whole presentation was based on linear algebra. It is a part of linear algebra, right? It's a golden subject. Linear algebra. Linear algebra leads to matrices and from matrices and other concepts. So, and we can go into the neural networks. If you are good in neural networks, you can work. You no need to go for any company. As a freelancer, you can work and you can earn in terms of crores. Because nowadays, people are searching for good neural networks to support machine learning and other related things in machine learning. Only mathematicians can do this, right? Okay. So only mathematicians with very good knowledge in the linear algebra and very good knowledge in calculus, because neural network means it only supplies the data, how to assign, how to get outputs in terms of machine learning. That's neural network. So who can deal neural network means it is actually a part of mathematics. It is actually a part of mathematics. The transforms, all type of transforms are used, and even partial differential equations are used in that neural network, right? So if you are good, if you start practicing, means you no need to go to any company. You can work as a freelancer. You can earn in terms of crores. Now, சொல்றது புரியுதா, my dear students? Okay. So the thing is, you have to practice. What do you mean by practice mathematics? In college, in classroom, teachers are teaching mathematics. Okay? Teaching mathematics. நீங்க என்ன பண்றீங்க? They will teach, they will cover the syllabus. After that, what you will do? So the brilliant students will cover the whole topics, whatever the teachers covered in the class. Average students select important questions and cover, right? Okay, so this what we try to do, right? This is not practicing, okay? So this is just studying. When the point practicing starts means, suppose you are going to a library and suppose you are referring some book on calculus, or suppose you are start referring something in differential equation or something in linear algebra, what your teacher has not covered, if you start learning that newly, okay, if you are going to start reading or if you are going to learn something newly means at that time, the practicing will start, okay? So develop this attitude, my dear students. With this, I'll go to my presentation. Actually, my presentation is also based on this linear algebra. So, Sir has explained about the eigenvalues. My starting point is also eigenvalues only. So, can anybody tell me, so from the Sir's presentation, so what did you learn from that eigenvalue concept? Eigenvalue concept வந்து என்ன புரிஞ்சுக்கிட்டீங்க? What did you learn from the concept of eigenvalues? சொல்லுங்க, something wrong, right? Okay. Yeah. Eigenvalues? Very good, very good. Actually, I have not prepared proper slides. So one thing I can say, so T is a transform. Actually, transform means eigenvalues means suppose vector is here means so vector is here means eigenvalue. Suppose lambda is greater than means it is enlarged or it is synced, but only in this line. Only in this line. Okay, right? Only in this line. Actually, transform means suppose here you are having some point x means so t of x means it may be anywhere here, right? T of x. So any point can be transformed into some other point, right? But in eigenvalue means so the point is here means it is oscillating or it is moving only in this line, right? Only in this line. Only in this line. Transform means generally points you are somewhere here means it can move anywhere, right? It can move anywhere. Okay, but the eigenvector moves only along this line. See, I would like to say some practical examples. Now Earth is there. Our Earth. Bhumi irukku. It is rotating. Our Earth is rotating, right? Our Earth is rotating along some axis. Okay, along some axis. So when rotating along the axis, actually what is happening means, suppose a particle is here means, the particle is pulled towards the center. Yes or no? Now, சொல்றது புரியுதா? Earth is there. The axis, along this axis, the Earth is rotating, right? Rotating means some particle is here means it is pulled towards this center. And some particle is here means it is also pulled towards. Okay, so the particle is pulled towards means it's a transform, right? Similarly, everywhere it is pulled towards this center. Yes or no? Right. Now my question is, some particle is here on the axis. Some particle is here on the axis. What will happen to that particle? What will happen to that particle? Can you guess? What will happen to that particle? Nothing will happen. Okay. Nothing will happen. So the transform will not affect. It will oscillate somewhere within this. Okay, so there is no much disturbance for this particle. Okay, now I give you one more example. You are having in your class, you take some BSc mathematics, third year. Consider the topper, always getting 100 marks. Okay, and some average students. Actually, you are all not average. I believe there is no the concept of average. Okay, so for this to discuss this, I'm taking this average students getting some 30-40 marks. Suppose university is giving a kind of tough question paper, right? The question paper is the transform. Tough question paper. What will happen? And the 40 marks for a student, sometimes what will happen? He or she may get 10 marks, 5 marks, right? Okay. The transform varies, right? But 100 mark getting students, again, he or she will get 100 marks, irrespective of the question paper, right? Okay. So this is one example. 2-3 examples. From that, what I actually want to say, நீங்க தான் கண்டுபிடிக்கணும். புரியுதா? First example நான் என்ன சொன்னேன்? Earth rotation. Second example, classroom. And I want to say one more example. நம்ம ரேஷன் கடைலாம் பார்த்துருக்கீங்களா? ரேஷன் கடை. அதுல பாத்தீங்கன்னா அரிசி வந்து ₹1 கொடுக்குறாங்க. ஓகே சார், அரிசி குவாலிட்டி இல்லை அப்படின்லாம் சொல்லக்கூடாது. இட் இஸ் ஓகே. ஸோ ₹1. Say in outside market, the price of the rice raise some ₹10 or ₹20 or ₹30. இன்னைக்கு வந்து per kg some 1 kilo அரிசி எவ்வளவு இப்போ? ₹60. Sometimes tomorrow it may go ₹70. Or after 2 weeks or 2 months, it may come down to ₹30. But நம்ம ரேஷன் கடையில கொடுக்குற அரிசி ₹1 தான் கொடுப்பாங்க. ஓகே, ₹1 தான் கொடுக்குறாங்க. So consider these 3 examples. From these 3 examples, what I want to say, what I want to communicate to you. நான் என்ன சொல்ல வரேன்? அந்த 100 marks வாங்குற ஸ்டூடெண்ட்ஸ் அவங்க கிட்ட என்ன இருக்குது? Stability is there, right? Stability and consistency. Okay, it is not the external system. It is not he is not disturbed by the transform. Am I correct? Similarly, in the earth axis, consistency is there, stability is there, right? Stability is there. Okay, stability, right? Stability in the axis, the particles on the axis, stability. Similarly, our rice in the ration, ₹1 rice means stability, right? Okay, so wherever you talk about stability or consistency, you have to talk about eigenvalue. Okay, because the nature of eigenvalue, I told you, it will oscillate only on that line. It will not move. It will not change the direction, right? Change the direction means what? Change the direction means from here going here. It will not happen. It will oscillate here only. It will not change the direction. That is the stability. Okay, so the eigenvalue concept, wherever you want to study stability, you have to touch the eigenvalues. See, you are constructing bridges, right? Okay, bridges with more stability. You have to construct. Lot of factors are there. What kind of cement and what kind of structure, what kind of whether it is parabolic or other so many things you have to read. Okay, so many factors you can put into a matrix. Matrix is nothing but a transform. From that matrix, you can derive the eigenvalues. Using the eigenvalues, you can construct that is going to be the more stable factors for the bridge. Okay, not only that, you take any social problem. Recently, some 3 years back, COVID, right? Everybody is affected. It is nothing but everybody is affected. But in some Actually, we can see some persons were not affected. Not affected means they are stable. To study also. Okay, so wherever is required, you have to go for eigenvalues. Okay, so that is my message. And so here the stability through eigenvalues, and how to get eigenvalues means you required linear algebra, that knowledge. Okay, so the knowledge. So that's why I told you. So this linear algebra, it is a golden subject, right? It's a golden subject. Okay, so the linear algebra concept. Actually, practically, we cannot apply linear algebra directly. So we consider in terms of matrix. Okay, in terms of matrix. So eigenvalue for square matrix is possible, right? So this one side. Now the graph theory concepts are there. How many of you are aware of graph theory? Graph theory எத்தனை பேருக்கு தெரியும்? Raise your hands. Feel free. உங்களை ஒன்றும் கேட்க மாட்டேன், right? Yeah. Actually, see, your college structure is there means so your college structure can be considered as a graph. Okay, your principal office is there means it is one point. Your classroom is there means it is one point. Okay, so the entrance is there means it is one point. Okay, so the connectivities are there means connected. From entrance, there is direct road to your class means it is connected. Entrance and the road, your class is connected. There is no direct road means it is not connected. Okay, so to study mathematically, we cannot consider your college directly. Okay, so we required some mathematical format. The mathematical format is supplied by graphs. This is called a graph, right? Okay, so this is called a graph. So our aim is to study, to impose linear algebra on graphs. Okay? Linear algebra on graphs. So that field of study is called spectral graph theory, right? Actually, what do you mean by spectrum means collection of eigenvalues, right? Collection of eigenvalues are called spectrums. So, actually, graph theory we can study in various point of view. Algebraic graph theory is there. Trying to incorporate group theory in graph theory, that is algebraic graph theory. Topological graph theory is there. Trying to connect topological ideas in graph theory. And chemical graph theory is there, trying to connect so the chemical structures and studying graph theory, right? So various aspects are there. So here, this is spectral graph theory means connecting linear algebra with graphs. Because linear algebra, I told you, it's a golden subject. So graph theory means it is highly applicable. We can easily model any real life situation. We can model into a graph, right? Okay. So we try to connect linear algebra and graphs. So that is spectral graph theory. Okay. In graphs, we cannot study linear algebra directly into a graph. So the graph should be converted into a what? Into a matrix. Okay. So the graph should be converted into a matrix. So here it is called adjacent matrix, right? Okay. So the points are called vertices and the connections are called edges. So the adjacent matrices, right? Okay. So this is a square matrix. And can you identify anything from this matrix? அது வந்து ஒரு matrix. Apart from that, so many matrices. What type of matrix is this? எந்த மாதிரியான matrix இது? Diagonal matrix. Okay. அப்புறம் okay, unit. Sister is saying all the entries are one. Very good. Entries are one, right? Okay. Scalar matrix. சரி சொல்லுங்க, அப்படி சொல்லிட்டே வாங்க. Diagonal. Okay, diagonal கிடையாது. சரி. One important observation. Actually, this is required as a mathematician, the observation, right? You have to observe, you have to analyze, you have to research in multiple dimensions. பார்த்தோன்னே என்ன தெரியுது? நீங்க மிடில்ல வந்து ஒரு மிரர் மாதிரி வச்சிருங்க. மேலையும் கீழையும் பாருங்க எப்படி இருக்கு. Upper part is reflection of upper part is reflection of lower part. What is that? It is called symmetric matrix. No. Symmetric matrix. So this matrix is a symmetric matrix. I think you have studied eigenvalues. This is a question for the PG students. How many PG students are there? Can you raise your hands? PG students முன்னால உட்காரணும், பின்னால போயிட்டாங்க. Okay, this is for the PG students. Eigenvalues in symmetric matrix, real symmetric matrix. இப்ப நீங்க yeah. Okay, no problem. So eigenvalues in real symmetric matrix is always real. So that's the beauty. Eigenvalues in real symmetric matrix is always real. Sometimes you will get complex eigenvalues also. See, for example, you take simple matrix 0, 1, -1, 0. Okay, what are the eigenvalues of this matrix? Characteristic equation is x square plus 1 equal to 0. X square plus 1 equal to 0 means what are the roots? X is equal to plus or minus I. Okay, plus or minus I, complex roots. For a real matrix, complex eigenvalues are possible. But we should not get complex eigenvalues. If we get complex eigenvalues, we cannot graphically, we cannot imagine. First of all, graphically, we cannot imagine for complex matrices, complex eigenvalues, right? This is the adjacency matrix. If you go for spectrum, that is, if you go for value, simply you will get real eigenvalues. You can analyze further through graphs. Okay, you can analyze further through graphs. So the beauty is here, this is the symmetric matrix. Similarly, the matrix, so many things are there. Yeah. So these are the applications of eigenvalues in various fields. So, see, for example, if you take the structural energy, can you read? Eigenvalues helps to analyze the vibration modes and stability in structures. Stability in structures. On the 20-floor building you are constructing means stability is required in terms of earthquake or in terms of other natural disasters. It has to be stable, right? Okay, to analyze the stable in buildings, so we can use eigenvalues. That's what I told you. Wherever the stability and the consistency is required, you can use eigenvalues concept, right? So in economics, you can use electrical engineering, everywhere you can use. And okay, so these are all some graph theoretical terms. So actually, so we have matrix and we have graph. We connected graph with the matrix. So there we are able to get some eigenvalues. Okay, and there actually we can go for applications. So and how it is applied in chemical graph theory. Okay, so what do you mean by chemical graph theory means? So we are having the chemical structures, right? Okay, chemical structures means we can laboratorically we can analyze through experiments. See, for example, if you want to find boiling points for a structure means some benzoidical structures are there, some structure you take. Boiling point means you have to do experiments. So you require that particular equipment and the particular lab. In any chemistry lab you cannot do. Okay, particular lab, also in particular atmosphere, in particular temperature. Okay, so you have to do the experiment. So overall, what happens means to find that single output, you have to spend more than 1 lakh rupees sometimes, right? Okay, so the cost and time consumption. So the thing is that same boiling point we can predict to some extent through mathematical computation. For example, VNR index is there. If the VNR index is high means the boiling point is high. VNR index is low means the boiling point is low. Okay, so that type of indications are there. The computation of VNR index means it is purely a mathematical concept. Purely a mathematical concept. No laboratory is required. No equipment is required. You no need to invest any cost. Simply, you can convert a structure into a graph, and for that graph, you can find VNR index using the definition. So many methods are there. From there, you can predict this structure may have this amount of boiling point or melting point or this kind of elasticity. So many things. So you can analyze through the okay mathematicians. So without going to the laboratory, we can guess the chemical outputs, right? Okay. So that is the usage of chemical. That is the objective of chemical graph theory. Chemical graph is doing chemical experiments without going to the laboratory or without spending time in the laboratory, without spending cost in the laboratory. We try to find the output through mathematically, right? So that is the tool used is graphs. Okay, so that's graphs. So various techniques are there. So that concept is called chemical graph theory. Okay, so in chemical graph, try to incorporate. I told you. So eigenvalues are almost applied everywhere. Now the question is it possible to apply eigenvalue concepts in chemical graphs? Okay, chemical graphs means in terms of molecules, right? Is it possible to apply? So this man, his name is Ivan Gutman. He successfully applied the concept of eigenvalues, that is the concept of spectrums in chemical graphs, actually in terms of energy, right? Actually, so one type of, there are different type of energies are there. It is called pi electron energy, right? Pi electron energy means so different type of bonds are there between the molecules. Sigma bonds, pi bonds, electrons are there. Between the pi bond electrons, the energy transformation, it is called pi electron transformation. Okay, pi electron energy. Between electrons, the transformations in different formations happens. Okay, so it is called pi electron energy. So the Gutman identified that the pi electron energy of a molecule is nothing but, see the last equation. What is that? Last equation is sum of the modulus of eigenvalues. Sum of absolute values of eigenvalues is approximately equal to the pi electron energy between the molecule. Okay. See, find pi electron energy experimentally means it is very difficult. Okay. You require modern equipment, so you have to invest time and different laboratories required, right? But mathematically, this is the formula, simplest formula, right? Actually, it is not accurate formula, approximate epsilon, that's all. Okay. You know, epsilon is very near to, it is a real best approximation. So that's why we are putting equal, right? So this pi electron in the molecule can be derived through eigenvalues. So it is nothing but the sum of the absolute eigenvalues. So these are the finding by Gutman. So for pi electron energy, to find energy, nowadays energies, different type of energies between the molecules are also derived through different type of eigenvalues. Actually, so here we are talking about this eigenvalue alpha k means eigenvalue is derived from the adjacency matrix. Okay, adjacency matrix. So adjacency matrix, it is a basic matrix. Different type of matrices for a graph are there. For example, Laplacian matrix. Okay, so Laplacian matrix, signed Laplacian, non-signed Laplacian, and even other matrices are there. Okay, so at the end, different type of matrices are there. From different type of matrices, so we can calculate different type of eigenvalues, and nowadays mathematicians, they try to connect with different type of energies with the molecules. Okay, so that research is currently going on. Yeah, so these are some results regarding to eigenvalues. Actually, I thought of deriving see, this is the basic result. Spectral is the basic result. N complete graph Kn is 2n minus 2, and energy of complete bipolar graph is 2 times square root of AB. A is the number of partitions in one, the cardinality of the another partition, right? Okay, I thought of deriving this so that actually mathematician means we are seeing something means only mathematicians can do. Only mathematicians can do. Here in this proof, lot of matrix concepts are there. We are using rank 1 matrix. Can you guess what are the eigenvalue of rank 1 matrix? Anybody? I'll give you a special prize if you say eigenvalues of rank 1 matrix. Rank 1 matrix. Mobile lam paaka kudadu. Okay? Actually, that concept is applied here in this proof. Okay. So eigenvalue of rank 1 matrix is 0, n minus 1 times. And the last eigenvalue is trace of the matrix. Okay, so go and refer. Similarly, eigenvalue of rank 2 matrix is also there. Eigenvalue of rank 2 matrix is 0, n minus 2 times. Suppose the matrix is n cross n matrix. Okay, so eigenvalues 0 will appear n minus 1 times. And the last 2 eigenvalue satisfies some conditions. Okay, so this type of results are used. Also, suppose each column of your matrix is equal, sum of each column of your matrix is equal, that sum is also one of the eigenvalues. So many results are there. Okay, so mathematically in linear algebra, almost derived all results are used in the spectral graph to develop the theories. Theories development means, so I am showing some theorems. See, these are all actually developed theories, right? See, this is developed in terms of integral. Directly you can go to the spectrum. You can guess spectrum. Upper bound is this, lower bound is this. So many results. Actually, we mathematicians derived this. And R of G means the radius of the spectrum. Okay, so I'm not technically. So here, these are the applications. Already I have discussed with you. So this is actually a chemical structure. How it is converted into chemical graph means. So this is the chemical graph. What is happening? We are omitting the hydrogen bonds, right? Okay, so hydrogen bonds are, the hydrogens are compressed. So to study the adjacency matrix of the chemical structure, actually this is the chemical structure, no? This is the chemical structure. To derive the chemical structure, if you want to find pi electron energy of the structure, you have to go to this graph. This graph, okay? For this graph, you derive the adjacency matrix. From there, you go to the eigenvalues, add the eigenvalues, it is going to be the electron energy. So this another structure, corresponding chemical graph. So these are the discussions regarding the pi electrons. So almost you are hungry, I know. So I am going to complete, right? Yeah, these are, I told you, so various graph energies. Basically, two matrices are there. What are the matrices? Can you list? Research is going on different matrices. This is actually called matrix extended adjacency matrix. And the other one is called first Zagreb matrix. The corresponding energies. So it is related with different type of energies. And so this type of different type of matrices are defined and different type of analysis is going on. And this is actually how to work and how to apply the software. So from the chemical structures, we are drawing our usual graph using Hypercam and TopoCludge. It is some software. From there, you can construct adjacency matrix. From GAP software, you can construct the energy of the graph. Okay, so different softwares are available. Okay. So linear algebra can be applied anywhere. Now, the developing fields are machine learning, cloud computing, and any computer-related topics. So you can apply eigenvalues so everywhere. You can apply. The thing is how to apply. Where you have to apply, right? Enga apply pannu. I told you, no, where stability is required, there you. So you have to find out. Right? You can start your research, right? So once again, linear algebra is a golden subject. Usually what happens means linear algebra நீங்க என்ன படிப்பீங்க எப்ப group theory, ring theory அதெல்லாம் முடிச்சிட்டு டயர்ட் ஆயிட்டு linear algebra போவீங்க. group theory, ring theory படிக்கும்போதே உங்களுக்கு சுத்திரும். அதனால வந்து hating linear algebra. No, it is not like that. That is why when student is PG program, first they are studying linear algebra. After that, usual algebra, right? Okay. Thank you very much, students. I thank once again, sister, for giving this chance. I thank the management again. Thank you. Thank you very much. Thank you.
Any queries from the participants? Thank you, sir, for your wonderful and insightful explanation and for sharing your knowledge to lead us high.
Your presentation on spectral graph theory was a very relevant and innovative approach. We gained a lot through your presentation. Thank you, sir. We humbly request you to stay on the podium as we would like to present the certificate and a gift to you.